Well, welcome to MV Tutors. If you would like a session after this, then comment asking for one or visit our website and book one over there. Our website, you'll find it under the description of this video. But today we are talking about organic reactions. Now, this is a very tough topic, so you need to pay attention for real. It's not easy. But we will try to break it down to small, chewable chunk sizes, which will make you understand it very clearly. Now, I like to start my sessions with a vision in mind. Now, what's our vision today is to try and answer this past exam paper. Okay, that's our vision. Now, look at this. Look at this question. Look at this. This is what we have to answer. Check this out. Now, if you cannot answer any of these questions or do not understand what's going on here, then stick around because at the end, we will understand it and answer this question. Okay, so now what are the organic reactions that we are talking about here? There are mainly four main ones. Organic reactions. There's four main ones. The first one that we'll discuss is called oxidation. It's called oxidation. Sometimes it's called combustion. Same thing. That's the first one. The second one that we're going to discuss is called substitution. The third one is called addition. And then the fourth one is called elimination. Okay, so those are the four kinds of organic reactions that we will be discussing. All right, let's get right into it. Let's start with oxidation. What is oxidation or combustion? Let's call it combustion as well. The oxidation or combustion that we're talking about. So here we are basically talking about oxidation is the addition of oxygen. So we are basically just adding oxygen to a reactant. Okay, so you start off saying with two reactants. Okay, and then you end up with two products as well. Okay, so for example, you start with an alkane and then you add the oxygen. The products that you get in oxygenation, it's always going to be carbon dioxide and water, H2O, always, all the time. The tricky part here is always the balancing of the equation, because you have to balance these. Okay, so for example, let us start. These are standards. That's a standard. It's always going to be there, and those are standards, always going to be there. The only thing that changes is the alkane. Okay, so which type of alkane? Let's start with propane. Propane is C3H8. Okay, so we start with propane and then we add, okay, let me use a different color. We're going to add the standards, which are oxygen, and it's always going to give you carbon dioxide plus water, H2O. Now, like I said, the tricky part here is the balancing. When you are balancing, always start with the carbon atoms. Okay, so this side we have, under the reactants, we have 3. This side we have 1. So in order to balance the carbon atoms, we have to put a 3 there. Okay, the next thing you always balance is the hydrogen atoms. So hydrogen atoms on the reactant side, I've got 8. On the products, I've got 2. So to get 8, I need to put a 4 in here. And then the last thing that you always have to balance is oxygen. Make sure oxygen is the last thing you balance, because it's normally easier to do it that way. So let's see. How many oxygens do we have this side? We have 3 times 2, which is 6, plus 4, so 10 oxygen atoms. And then we've got, so in order to get 10 on the reactant side, I need to put a 5 here. Now it is balanced. Now, if you don't understand how to balance equations, make sure to book a tutorial session with me, and I'll gladly teach you. Okay, so let's talk about substitution. Okay, substitution. Okay, so like the word is suggesting, you are actually substituting 2 atoms. So even here, you start off with 2 reactants, and they should give you 2 products, because you just substituting. Okay, let me just demonstrate it with a drawing. So say just for convenience sake, you have a square that has a circle, and then this side you have a rectangle, okay, that has a triangle on top. Okay, now those are the reactants. Now when it comes to substitution in the product side, you're still gonna have your rectangle. Since I'm using this pen, and then you'll have your triangle. Let's just go back to green, and then over here you'll have your square. Okay, and then here you'll have your circle. So what just happened here? As you can see, we literally substituted. These stayed the same, the bases stayed the same. We substituted the top parts of it, okay, such that the circle goes to where the triangle is, and the triangle goes to where the circle is. So basically that's what we're talking about when we talking about substitution. Okay, so let's just talk about a few more details about it, so that we put it into perspective. So you can start off with an alkane, okay, and a halogen, okay, which will give you a haloalkane. So the halo goes to the alkane, so that we have a haloalkane. Plus a hydroxyl, or let me just call it HX. It's a hydroxyl. Okay, so this process is what we call halo. This is called halogenation. Okay, when you take an alkane and you add a halogen to it. Okay, and then let's just make an example, a quick example. I'll use a different pen. I'll use a structural one. So say you have that, you have H, that's an alkane, simple alkane. What's this alkane called? It's got 2 carbon atoms. Okay, so you need to know what this one is called by now. All right, so this is an alkane, a simple alkane, and then let's add a halogen. Say we add, what's this called? Do you know what this is called? Well, you should know it by now. If you don't, you know what to do. Book a session, we'll get through it. All right, so what happens here is that literally there's going to be substitution. Okay, and where is the substitution going to occur? Okay, so we need to take one circle thing here. Let's make this a circle. Let's say that's the circle part. Okay, and then from this side we need to take one triangular part. Okay, let's say that's a triangle, and then replace them. Okay, so if you replace them, what you get is the same thing. You got H here, you got H, got H, got H, got H, and there where we're replacing, we replace it with bromine. Plus, and then here you get place it with the hydrobromine. Okay, so there we go. So as you can see what happened there, we took the triangle to the other side, and then we took, as you can see, the triangle's over here. Now the base still stayed the same, and then the circle one is over there. That's it. Also, as part of substitution, we have what's called hydrolysis. Okay, so here is where you can take a haloalkane, okay, and with water, H2O, and then there you'll get an alcohol plus a hydroxyl. Just call it HX. Let's do an example. Let's take the same one that we got here. Okay, so we got C, and then we've got H, and then a Br. Okay, that's the haloalkane plus water. Functionally, you can write it like this, OH and H. Okay, so structurally, an alcohol, the functional group of an alcohol is an OH. So what we're going to do here is that we're going to substitute this with that triangle. Okay, let's go back to the red. Let's see. So you're gonna get that. That remains the same. And then there, that's where we put our triangle, which is an OH. This is the functional group that makes it an alcohol. Okay. Plus here, remember we're substituting the OH, so we're just going to have I'll write it the other way around, HBr. Doesn't matter. Okay, but the important thing is that now we have the circular part this side, and then we have the triangle that side, to put it that way. Also, that's not the only substitution we can make. Let's make another example where you can take the same haloalkane, which is C. We've got the H there. We've got the C. We've got the H. H, and then we got the Br there. But instead of water, this time we'll put sodium hydroxide, OH. We're still going to get an alcohol. Okay, so let's just put that in. That's still our circle. Okay, and then our triangle now is still the same one, which is OH. Okay, those are the ones that we substitute. Okay, so this side you're still gonna get the same thing with an exception of the substitution. So we still have our alcohol functional group there, which is that OH. Okay, and then this side what we are left with is sodium and then Br, if I'm to put it like that. Okay, all right, so that's it. So the third one for discussion is what we call addition. Addition. Okay, so with addition, you start out with two reactants and you end up with one product. So you take two things and you add them together. So for an example, you take a square or a rectangle, you add it to a circle, and then you get, let's say which one is bigger? Let's say the square is big, the rectangle is bigger. You get one product that's gonna look like that. Okay, now the other thing that we need to discuss here is that the reactants, they are actually unsaturated. Okay, what does unsaturated mean? It means they've got double bonds or triple bonds, so either they are alkenes or they are alkynes. That's what saturated means. But the product that's one is actually what we call saturated, which means it's got single bonds, so it's alkanes. This is always going to be the point, the case. It's always going to be unsaturated giving saturated products. Okay, let's do some examples of addition. The first one that we have is what's called hydrogenation. You take an alkene. Okay, alkene is unsaturated, and you add hydrogen atoms and you get one product, which is going to be an alkane. Okay, so that is what we call hydrogenation. And then we also have halogenation. Halogenation, you take a haloalkane and then you add halogen. Okay, sorry, remember we said it should be unsaturated, so haloalkene, and then you add a halogen so that you have one product which is a haloalkane. Okay, so don't get confused here. And then another one that we have, so this is our first one, this is our second one. Let's do a third one now. The third one is what is called halogenation. Okay, so the naming, it comes from what you are actually adding. So here you are adding an alkene to a hydroxyl group. Okay, and then what you are going to get is a haloalkane again. Okay, so the halo comes from this halogenation. Okay, and then the last addition is what we call hydration. Okay, so hydration, you take an alkene and you add water. Just like when you're thirsty, you drink, you are essentially hydrating yourself. When you drink water, that process is called hydration. Okay, so here you get an alcohol. And remember, the functional group of an alcohol is OH. Okay, let's do just one of them, a structural example of one of them. Let's take hydrohalogenation. Okay, so we need an alkene. Let's say this is our alkene. Remember, what makes it an alkene? It has a double bond. Okay, so we've got H here, H there, H there. We've got H there and a H there. It's complete. Okay, oh, this one needs one more H. Okay, and then plus okay, let's see. No, actually, let's take a halogenation. So the halogen that we're going to use is chloride. Okay, so that's addition. We're adding chloride and an alkene. The naming of this alkene, what is it? I'll leave that to you. But let's just write the structure of it. So we are supposed to get a haloalkene. So we have single bonds all the way. Okay, so we have our H there, our H there, our H there, H there. This one had an H there. Now what we have done is that we're going to take this chlorine and put it over there. So we took that and we added it over there. Okay, so that's all we did. That's addition, essentially. You can do the same with all of these hydrohalogenation. We just did halogenation. You can also do it with hydrogenation. Okay, now I want us to talk about the last one, which is called elimination. But before we go there, let's just go back to addition. There's something I want to add here. Under hydration, you do hydration under the presence of what's called H2SO4. Okay, so here we would also have to have H2SO4. It's like a catalyst. And then when it comes to hydrogenation, we normally use what we call platinum, PT, platinum. The rest, they don't really need catalysts. Okay, now let's talk about elimination. Elimination is the exact opposite of addition. Addition, you are adding two things and you are coming up with one. Here under elimination, you've got one reactant which is giving you two products. Okay, so in terms of shapes, you already have a shape like this, which is circular with a square. That's one reactant. It's giving you two products. It's giving you a circle plus the square. Okay, so two products. And then this one product is actually saturated. And then the reactant is saturated, and then the products, they are unsaturated. Remember, we've discussed that saturated means single bonds. So that's an alkane. Okay, that's an alkane. And then unsaturated is double bonds. So you've got two bonds or triple bonds, like that, between the carbon atoms. Okay, that's it. So let's now discuss the types of eliminations that we have under organic reactions. The first one I want us to talk about is this one called dehydration. Okay, like we spoke about it in addition, it involves water. Okay, so you're taking out water. In addition, you are drinking water. Dehydration, you're taking out water. Just like when you go through diarrhea, you're taking out water from your body, so you get dehydrated. That is a simple example of dehydration. So you start with an alcohol. Okay, that's our one reactant, and it becomes an alkene plus water, because water is what you are taking out. Okay, and then the next one is dehydrohalogenation. Okay, so we have a halogen here. It's opposite halogenation. Okay, the one product that you're starting with is a haloalkane. Okay, so from there you had an alkene, exact opposite of the addition one. An alkene plus hydroxyl. Okay, so this was the first one. That's the second one. The third one is what's called dehydrogenation. Okay, this as well is where we're starting with the alkane, exact opposite of the addition one. Okay, and it's an alkene plus hydrogen. Okay, so the hydro comes from hydrogen. Wherever you have a hydrogen atom, it's a hydro. Okay, that's why even here there's an hydrogen, so it's a hydro. But because there's a presence of a halogen, so you add the halogen part. Here there's no halogen, so it's just hydro. So it's dehydrogenation, taking out hydrogen, eliminating it. And then the fourth and last one, this one is called cracking. Okay, it's a bit of a weird name, but basically it's, you start off with an alkane, okay, and you break it down, you get an alkene plus an alkane. Okay, but what I just want to add is that cracking, you do it under the presence of platinum again. Platinum is very popular under organic reactions. And then dehydrogenation, also platinum. And then dehydrohalogenation, you do it under the presence of sodium hydroxide, which is the other popular one. And then the other, dehydration, you do it under the presence of H2SO4. Okay, so those are the catalysts that we use. Okay, let's just do one example. Let's take dehydrogenation. Okay, so it's an alkane. Let's start off with an alkane, a simple alkane. C. Got an H there and an H there. So each and every one of them has 4 H's, just like how I'm drawing it right now. So that's what you're starting with. You break it down under the presence of platinum, okay, and then you get an alkene. Remember, an alkene has a double bond, so it's gonna start with an H. You've got a C there. Let's put the double bond C and then the last C. Okay, and then you have an H there, an H there. This one has an H, an H, and an A. Plus H2. Okay, plus H2. You can do it like that. Let's just do it like that. So what did we eliminate here? We were not adding, we eliminated 2 H's. Okay, those 2 over there. Okay, so as you can see, they're no longer there. And where did they go? They came here. That's it. Now we can go back to our question to try to answer it, our past exam. Okay, so here we go with our question. The flow diagram below shows how an alkene can be used to prepare other organic compounds. The letters A to G represent different organic reactions. Okay, so first question is, write down the type of reaction represented by A. Okay, so where's A? There is A. Propane is there. Okay, so to move from propene to propane, let's just draw propane. Remember, propane has single bonds only. Okay, so it's single bonds all around. Okay, all of them have H. So what we did here, we needed to add something in order to get these 2. We needed to add, see, 2 extra, let me just put them in a different color. We added 2 extra hydrogen atoms. So A, then the answer to A becomes that A is actually what we call addition, because we added. Okay, and then B, where's B? B is over there. So we're moving from propane to compound Y. But what is compound Y? Okay, so compound Y has HCl in it. So it's like this. Let's just draw it out structurally. We've got H, 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 and then HCl. Let's put the H there and the Cl in the middle. Okay, so how do we move from this to that? Okay, what you can see here, let me just use a different color, is that what we did, we just basically, how we move from here to there, is that the difference is that we have an H atom here. Let me use a different color. This H atom was substituted with this Cl. So what we have here then is what we call substitution. Okay. Substitution. Okay. Now let us look at E. Where is E? From E we moved from an alcohol to a propene. So if you remember your theory, to move from alcohol to a propene is elimination. Okay, but just in case you want to see it more clearly, we can actually draw out alcohol. So the alcohol will be like this. Let's draw it out structurally so that things make sense to you. We'll put the OH there. That's the functional group of an alcohol. Okay, so what happened here, as you can see, we added water and then it became an alcohol. So now going the opposite way is what, let me use a different pen as well. We'll use green. So moving from this, from the alcohol to the propene, as you can see, what actually happened there is that we're moving from one saturated reactant and we're getting two unsaturated. So unsaturated, which is propene and water. So that is what we call elimination. Okay, because we're moving forward. Backwards. If we're moving forward, it would be addition, as you can see, but moving backwards is now called elimination. Now, the next question is, write down the IUPAC name of compound X. Okay, let's write compound X. So as you see, from compound X, we added hydrogen and bromide. So let's just draw it out so that you can see what it is. So we have that. Let's put our bonds. Okay, so I'll put bromide there. The rest of them have H's. Let me just put them for control, because some of you want to actually see the H's. All right, so now the IUPAC name for this, what I just put there, remember we added H and Br to propene, so there's the H and there's the Br. So the name of this, first of all, it's a propane. Okay, because it's got 3 carbon atoms, and it's an ane because it's got single bonds. And then it's a halogen because now there's a Br there. So we call it, and it's on position number 1, 2, 3. It's on position 2. So we'll say 2 dash bromo. So it's bromopropene, 2-bromopropene. Okay, and then it says for reaction D, let's identify reaction D. Okay, so reaction D, we're moving from the halogen to an alkene. Okay, so what type of elimination is this? Remember, we had 4 types, and the one that has a halogen is called a D. It has a halogen, it also has a hydrogen bond, so it's a dihydro. And then because of the halogen, and then halogenation. Okay, and then it says for reaction D, write down 2 reaction conditions. Now, if you remember your theory, we said it must be done under the presence of an OH. But what I didn't tell you is a second condition is that the temperature must be high or hot. So let's just say high temperature. So it must have high temperature as well. Those are the 2 conditions. So 4.4 says write down the formula of an organic reactant needed for reaction F. Let's go look at reaction F. Reaction F, we're moving from the halogen to an alcohol. Okay, so to move from halogen to alcohol, alcohol has an OH, so we need to add water. And the formula for water is H2O. Right, now they say balanced equation using structural formulae for reaction G. So reaction G, we're moving from an alcohol to a halogen. Okay, let's just write the structural formula for an alcohol. Well, we already have it there, but let me rewrite it here. Okay, so we have C, and then an OH there. Okay, I'm not going to put the 8 H's for now, for simplicity, but what we want to get is that halogen. Let me rewrite it exactly as it is as well. So for the halogen, we have C, and then we have chlorine there. So we need to add something to the alcohol in order to get a chlorine. And remember, the chlorine this is the only chlorine atom. The rest are H's. Okay, so maybe let me just put them so that you see things in perspective. Okay, we have H, got H there, got H there, H, and H. So all we have is OH is this side, and this side is Cl and H. So we need to add, okay, HCl. Okay, and now when we add HCl this side, and here we've got a Cl, so, and we also have an OH that side, so this side then we need to balance that with the HOH. Okay, so we did a substitution. Let me just show you where the substitution was. We had an OH circular there and a triangular Cl. So the Cl came here, triangular Cl, and the OH substituted over there. Well, that's it. Hope you understood, but in the event that you didn't, do hit me up and I'll be glad to tutor you in these matters.